So far, throughout this series of Scala courses, we focused on the basics of functional programming, and we focused in particular on sort of learning the fundamentals and slowly but gradually building up more and more interesting programs from these fundamentals. And this was in the courses number 1 and 2. So principles of functional programming in Scala and functional programming design in Scala. Then we moved on to the parallelism course, where we started to focus on the underlying executions of our computations in a parallel setting. In this course, we're going to continue that trend. And we're going to begin to think about applying some of these fundamental functional concepts across many machines rather than many processors. We'll also begin to shift our thinking towards a class of applications, unlike we've done before. So we're really going to start looking at analyzing large amounts of data, which is typically the focus of data scientists. That said, it's important to note that this isn't a machine learning or data science course. Rather than focusing on machine learning algorithms or designing and tuning models, we will instead focus on how to map some of the functional abstractions that you've learned in previous Scala courses to computations on multiple machines over massive data sets. That is, we will see firsthand how the functional abstractions that we've covered in the previous Scala courses makes it easier and more user-friendly to scale computations over large clusters, or easier per se than scaling computations on imperative frameworks, imperative systems for distributed computation. However, as alluded to earlier, in our programming exercises, we're always going to focus on analyzing large data sets. That is, you'll be challenged to think about common data science tasks like k-means functionally, such that they can be adapted to and implemented in the context of Spark, a functionally oriented framework for large-scale data processing that's implemented in Scala. Before we go any further, you might be asking, well, if we're going to be focusing on a lightweight data science-y flavor of processing tasks, then why are we bothering with Scala and why are we bothering with Spark? After all, if we want to learn data science in the classroom, often statistics professors favor languages or frameworks like R or Python or Octave or MATLAB. So then why should one bother learning Scala or Spark, which are both arguably very unlike R, Python, Octave, and MATLAB? The answer is that these languages and frameworks are good for data science in the small, algorithms on datasets that are perhaps just a few hundred megabytes or even a few gigabytes in size. However, once a dataset becomes too large to fit into main memory on one computer, it suddenly becomes much more difficult to use one of these languages or frameworks alone. In short, if your small dataset grows into a much larger dataset, then these languages and frameworks like R, Python, MATLAB, etc., they won't allow you to scale. You'll need to start completely from scratch, re-implementing all of your algorithms using a system like Hadoop or Spark anyway, or you'll need to manually figure out how to distribute your problem over many machines without the help of such a framework, which is kind of a bad idea if you're not already an expert in building distributed systems. And oh yeah, there's also this whole huge, massive industry shift towards data-oriented decision-making. Nowadays, many companies across many different industries have realized that by looking more closely at the data that they're collecting, from device logs to health or genetic data, they can innovate in ways that were impossible before. For example, now we have all of these devices surrounding us collecting information and attempting to provide all kinds of insights to enrich our day-to-day lives. Or instead, imagine hundreds of thousands of users of some device, say a smartphone or some wearable or something, and imagine as part of your job, you're responsible for providing some analysis or insight behind all of the data that's collected, be it providing insights to the smartphone's manufacturer about how the smartphone is operating. You know, it would be nice, for example, if your smartphone manufacturer was able to catch an updated glitch before it became a big problem for you, or analyses of your level of physical activity relative to the average activity of other users using the same wearable as you. For example, in both of these cases, the language or the framework that you might have learned in a statistics class couldn't be used as you learned it. These are data science problems in the large that I'm talking about, and they can't be solved on a single compute node alone. On all of these kinds of problems, scale far beyond the tech industry alone. You'll find similar problems in medical research. Lately, there's a number of initiatives focused on developing personalized treatments for disease, for example. You'll also find similar problems in finance, manufacturing, and many other areas of industry. In short, almost every industry has moved towards improving their business or products using some kind of data science, very often using data science in the large. So then let me ask again, why Scala and why Spark? So, okay, we established that R or MATLAB as you learn it in school isn't going to work for these data science in the large situations that are of increasing importance across industries. But by using a language like Scala, it's easier to scale your problem to the large with Spark. whose APIs are almost one-to-one with Scala's collections. That is, by working on Scala in a functional style, you can quickly scale your problem out from 1 to tens, hundreds, or even thousands of nodes by leveraging Spark, a successful and performant large-scale data processing framework which looks a lot like Scala collections. So let's start by touching on a few reasons to learn Spark. When it comes to dealing with large datasets, Hadoop is also a popular choice, so why would anybody bother with Spark? Well, there are a few very strong reasons. One, Spark is more expressive. Spark's APIs are modeled after Scala's collections, which mean distributed computations in Spark are like immutable lists in Scala. You can use higher order functions like map, flat map, filter, and reduce to build up rich pipelines of computation that are distributed in a very concise way. Whereas Hadoop, on the other hand, is much more rigid. It forces map then reduce computations without all of these cool combinators like flat map and filter, and it requires a lot more boilerplate to build up interesting computation pipelines. The second reason is performance. By now, I'm sure you've heard of Spark as being super fast. After all, Spark's tagline is lightning fast cluster computing. Performance brings something very important to the table that we haven't had until Spark came along, which is interactivity. Now it's possible to query your very large distributed dataset interactively. So that's a really big deal. And also, Spark is so much faster, Hadoop, in some cases, that jobs that would take tens of minutes to run now only take a few seconds. This allows data scientists to interactively explore and experiment with their data, which in turn allows for data scientists to discover richer insights from their data faster. So something huge, which I feel isn't often mentioned when people are talking about the pluses of Spark, is that it really improves developer productivity. This is a really big point here. Spark improves the productivity of data analysts. And finally, Spark is good for data science. In fact, it's much better for data science than Hadoop, and it's not just due to performance reasons. Iteration is required by most algorithms in a data scientist's toolbox. That is, most analysis tasks require multiple passes over the same set of data. And while iteration is indeed possible in Hadoop with really quite a lot of effort, you have a bunch of boilerplate that you have to do, and you've got to require external libraries and frameworks to generate a bunch of extra MapReduce phases in order to simulate iteration. It's really, on the other hand, downright simple to do in Spark. There's no boilerplate required whatsoever. You just write what feels like a normal program, which includes a few passes over the same data set. You just have basically something that looks like a for loop and say, hey, until this condition is met, iterate, which is like night and day when compared with Hadoop, because it's almost not possible in Hadoop.